Omega is a digital learning resource on the remarkable science of infectious diseases, immunisations and epidemics. Lesson 10 is on statistics and vaccination. By doing this lesson, students will learn how to determine how effective vaccines are and then to work out the herd immunity threshold, how we can protect the entire community through vaccination. Vaccine effectiveness is the proportion, the percentage of people who are protected by a vaccine. Generally, it's between 50 and 95%. We estimate it, for example, by looking at 10 people who are susceptible, vaccinating them, and if only 2 of them get infection, then you've got 80% vaccine effectiveness. R0 is a funny sounding term. It's the basic reproduction number, R0. And what it means is that if you've got one infected person in a completely susceptible population, the number of secondary cases that occur is the R0. So if there are 2 people who get infected by that one person, the R0 is 2. Herd immunity comes from veterinary medicine. It refers to cattle, but it also refers to people. The better term for herd immunity is community immunity, and it's the indirect protection that arises in a population when a large proportion of people are vaccinated, so that the vulnerable, the susceptible, are protected from transmission because all of the vaccinated people prevent the germ from transmitting through the community. So community immunity or herd immunity occurs when enough people are vaccinated that a disease stops from spreading. For measles, very infectious, you need 90 to 95% of people to be vaccinated to stop spread. For polio, it's a bit less, 80 to 85%. And for some bacterial infections, it's only 50 or 60%. So when we say that you need 95% vaccine uptake to stop measles from spreading, that's called the immunity threshold. Once you achieve that high level of protection, measles, the virus, can't spread through the community. As humans, we gain immunity from infections by getting sick and then recovering with antibodies, or by being vaccinated, which is much safer. Either way, you can get to a threshold, a high enough level of immunity in people due to infection or to vaccination, that immunity stops spread within the community. Almost all germs are transmitted by people to people. We get some from animals, but almost all come from other humans. Germs usually make you feel unwell for a few days, perhaps a week or 2, during which you can infect other people. And then you recover, your symptoms like a cough go away, and you get immunity so that you can't get that particular infection again. If each infected person with symptoms passes their germs on to at least one other person, then we have the situation where a germ, a disease will survive because you get 1 to 1 to 1 or more. If, however, you can stop the spread of one to another so that it's less than 1, the disease will peter out. And that's what we aim to achieve with vaccination. So if each infected person on average infects 2 others, 1 becomes 2, 2 plus 1 is 3, and those 2 can then infect 2 others and make 4 infections, so that's 7 people who are now infected. So you can see how quickly an outbreak can develop. So if on average 2 people are being infected by 1 person, that's called a reproduction number of 2. Now for measles, which is so very infectious, 1 person on average can infect 10. And then those 10, if they infect another 10, you've got 100 infections. So clearly you've quickly got an outbreak. But if the majority of people who are exposed to the measles case are already immune through vaccination and perhaps prior infection when they were very young, then the measles can't keep transmitting and you get a block. And that's where we look to find the big enough block to have the immunity threshold for prevention of transmission. We can use the reproduction number to understand how infections transmit through a community. The aim is to get to the stage where the proportion of people infected second time round is less than 1. Because if it goes from 1 to less than 1 to less than 1 a bit more, you eventually get down to 0 and no more cases. So not every case will cause another case, and the chain of infection will eventually stop. Immunisation is the safest way to achieve this. Let's say a case of measles is caught by a baby visiting overseas on holiday in the Philippines, and it comes back on the plane still infectious, still with a fever and a rash, and starts to infect people back in Australia. Remember, we need to get that reproduction number down to under 1, because if secondary cases are fewer than the primary case in number, the disease just has to burn out. So here's an example. If 90% of the population are immune through vaccination, then that sick child with measles coming back on a plane from overseas from a holiday can only transmit to 1 in 10. That's 10% because 90% are immune. So therefore, one case only can cause one other case. But we want it to be less than 1, so you just need to have a little bit more than 90%, say 90.1%, and then the virus eventually has to peter out because it just can't go on spreading. Now here's how we very simply work out the immunity threshold. The immunity threshold is the proportion of the population, the percentage, who are immune such that you cannot have a disease continuing to transmit because it keeps knocking into well people who knock it back. Here's the simple mathematics that's required. 1 minus, in brackets, 1 divided by the reproduction number, close brackets. So we start with 1, that's pretty simple, and we take away from that a proportion, 1 divided by R0. Now for measles, let's say it's 10. So 1 divided by 10 is 0.1. 1 minus 0.1 is 0.9. So that proportion, 0.9, could also be expressed as a percentage, 90%. And that is the immunity threshold for a virus like measles that is very transmissible but can be controlled. Statistics can really be quite fun because they help you to understand the world. Let me give you a funny example. Where we've got lots of vaccination against a disease, let's say measles, we get lots of protection. Then when people examine the small measles outbreaks that sometimes occur, they can find that the proportion of people with measles who are vaccinated is the same as the proportion who are not vaccinated. Now that looks very curious. So we've got 90% of people vaccinated against measles, but 10% are not. So this measles epidemic comes along and those 10%, let's say 10 in 100, get measles. But the vaccine is not perfect. It's about 90% effective. So 9 times 9 is 81%. So 81% of the 90% are protected, but 9% or 9 in 100 get measles. Therefore, we have 9 people who are vaccinated getting measles and 10 people who are not vaccinated getting measles. And you think, oh, look, we've got the same number of people in both groups. But that's forgetting that 81 out of 100 are protected by vaccination and not getting measles. So there you have to understand the benefit of vaccination, that even if you see in a proportion of sick people a similar amount who get measles who are not vaccinated to the amount who get measles who are vaccinated, you have to understand the background to that 81 out of 100 were already protected.